Morning. So last time we stopped at routing loops and we said why we will have routing loops. This may happen because of packet is continuously transmitted within certain router without reaching to its destination, and this may happen because of periodic updates and sending all routing tables between different routers and a distance vector routing protocols. For example, if you have one link unreachable and this update is delayed to be sent to R2, R2 will still have this route and consider it as a reachable and will send back to R3 that this route is still reachable while it's already removed or unreachable. So due to the delay and due to periodic updates, we may have some routing loops. And we discussed different reasons for routing loops and the effect of routing loops. Then we started by the first solution to solve the routing loop problem. First solution is to set a maximum. What we mean by maximum, we will set maximum hub count or maximum number of hubs. So when we found unreachable link, the directly connected routers will directly update the number of hubs to the maximum, and the maximum here will be 16, and then propagate these updates to the other routers. And even if there is routing loops, using a TTL time to leave in the IP header, we can avoid these routing loops by decreasing this time to leave, and if we exceed the number of hubs, we will drop this packet. Second solution to avoid routing loops using hold down timers. So to avoid routing loops, we can use a hold down timer. What we mean by hold down timer, we allow router to not accept any change to a route for a specific period of time. So for example here, router 3 detect that this link or this IP 10 to 10.4.0.0 is unreachable. So it will not remove this entry immediately, but it will put this entry or this route into hold. So in this case, I will not accept any information about this and then propagate this update to the other routers. Routing problems, what's the reason for routing problems in R2 can send back this information to router 3. This is what causes routing loops. When this is unreachable, and the updates get delayed. So R2 will send periodic updates. So I will add it again. So to avoid this, I will put onto hold. So when I receive new information from R2, for example, says that this link is still reachable, I will not update my entry because I put this in hold because I know this is unreachable. So I set timers and put this entry in the routing tables or this route into hold. So even if by mistake R2 send to me it's reachable, I will not update my link. I will consider it as unreachable until my updates propagate to the network and all other routers update this entry to be unreachable also. But did you see how we solve this problem? And the problem of routing loops can, what is the reason for routing loops? And these updates reach a long time or after delay to the other routers, the other router is still assuming in this route exists. And then this router that this route is still exists. This causes a problem. To avoid this part, we will put this entry into hold. So when I propagate or I receive any information about this route, I will not update my routing table because it's in hold until this information reaches to all other routers and all of us update this entry. It's unreachable, it's unreachable, it's unreachable. Okay. فالhold down timer is used to prevent unreachable or bad routes for being propagated. So when a route is placed on hold down state, neither advertise nor accept any new information about it. خلاص, it's unreachable. I will not remove it because if I remove it and receive new information from R2, I will add it again. This will cause a problem. So I will not remove it. I will keep it for a certain hold down timer to know that this is unreachable. Even if I received any information about it, I will not update my routing table because it's on hold. Okay. But using this hold down timer, I can avoid routing loops. Clear this method, hold down timer? Okay. The third method is split horizon rules to prevent routing loop. Split horizon rule, what is this rule? If a router, any router shouldn't advertise a network through the interface from which the update come. Then again, the problem happen when this link is unreachable and I remove this link, but R2 still doesn't remove this link and send me back the same information again, so I add it again. And the problem can come when this I send this link belongs to R3. So I send this information to R2. This link belongs to me. You can reach to this link through me. R2, why R2 should send back same information for me? And this IP can reach through you. I already know this information. I am, يعني, you can assume that I am the owner of this information. This link belongs to me. But I propagate update about this link. So I will not receive the same information again back from R2. I will avoid this split horizon rule. R2 shouldn't send the same information to R3 again. So if this link become unreachable, R2 will not send me again, it's reachable through you. This is split horizon rule. We shouldn't advertise the network through the same interface. And update of this link coming from R3 to R2. So R2 shouldn't send back the same update to R3 to avoid routing loop. And if I remove مثلا this link and this update come to me before I am confirming R2 is unreachable, I will add it again. But to avoid this, if you receive update from a certain link, you shouldn't send back the same update through the same link. If a neighbor router send a route to a specific router, the receiving router will not propagate this route back to the advertising router. And this router is advertising router. I send to all network, there is a link with 10.4.0.0. So the other router shouldn't send back to me, there is a link 10.4.0.0. I am the owner, I am the advertising. I am this router who sends this information. So other router shouldn't send back to me the same information again. Why? To avoid if I update anything about this link, avoid conflict from receiving old information from other routers. To avoid receiving old or wrong updates from other routers, we will not accept any updates back to the same advertising router. Clear? And this all this method try to avoid the reasons of routing group. Reasons of routing group, I am updating my entry and the update doesn't reach yet to the other routers and other routers send me back the same wrong information. This is the problem. But I'm avoiding it using different methods. One method is setting a maximum. Because I will set this maximum number of hops. So if I receive back information, I will find its maximum number. I will reach to the maximum number of hops and stop and drop the packet. Second is to put hold down timer. So I will put this in hold. So if I receive wrong information about this link from other routers, I will not update my table. Third is to avoid back sending from the beginning to avoid sending back the same information to the source, to the same source. And this is the source of the information. So I will not send updates about this route to the source of this route. And this is the owner of this route, or this is the source of the information. I will not send back the same information to the advertising route, to the advertising routers. Okay? Clear? This is split horizon rule. يعني updates or new version of this method is split horizon with poison reverse. In this case, to be more conservative, And to avoid also routing loop, I found this link unreachable. I will set number of hubs to the maximum, and I will send poison poison signal to all other routers. This route is unreachable, so I will send immediately trigger updates or poison updates. Take care this link become unreachable. Okay, and to make sure that all routers receive this information, once R2 receives this information, we send back to R3. I receive this information, it's and send back the same poison update again. I receive this poison updates. The rule states that once a router learns of unreachable route through an interface, it will advertise or send unreachable back through the same interface. So I received here, مثلا R2 received this link is unreachable. I will send back through the same interface this link as unreachable. Why? To confirm to R3, I already received and I already know that this link is unreachable. So once I received from any interface that this link is unreachable, I will send back the same information. This link is unreachable through the same interface. They have poison update. Poison update, and it means this specific link is unreachable. And when a router detects that one of its connected routes has failed, the router will poison this route. Poison this route, it means assigning infinite number of hubs or infinite metric to it. And infinite here, the definition of infinite is 16. 16 is the definition of infinite. So I will put infinite metric, infinite value to the metric. It means that it's unreachable and I poison this route. And I consider this route is unreachable. Okay, and I will send trigger update to all other routers. Take care, this is unreachable route. Okay, any question? But now to avoid routing loops, we have four solutions to avoid routing loop. One is to set a maximum by setting a maximum number of hub. To, say, so if the packet is reached to the maximum number of hubs through different loops, I will drop this packet. Second, to use hold down timer. So if specific link is unreachable, I will put hold down timer for this route. So I will not accept any updates about this route for a certain amount of time to make sure that all networks already receive this information that this link is unreachable and to avoid exchanging old wrong information. That means that it's reachable. So I will avoid exchanging old wrong information and I will consider this route for a specific amount of time on hold. Third method is split horizon rule. So I will not advertise the same information back to the source of the information, or I will not send back to the same router the same updates. For example, R3 send updates about this thing to R2. R2 shouldn't send back the same information to R3 again. And third method is split horizon using with poison reverse. In this case, once I receive one link is unreachable, I will set it to the maximum and I will set trigger updates to all other routers. This link is not reachable and the metric is infinite. Okay, any question? Now to go specifically for RIP protocol as an example for distance vector routing protocols, because most of the previous rules was general for distance vector routing protocols. Here we will consider a specific characteristic or a specific feature of a RIP as an example of a distance vector routing protocols. What are the main features of a RIP or main characteristic of a RIP protocol? First, it supports or uses split horizon and split horizon with Poisson reverse. Second, it supports or use load balancing. And طبعا all this definition we already discussed. It supports load balancing. Third characteristic, it's easy to configure because it's use distance vector, and as we said last time, distance vector is easy to be implemented, but the disadvantage is it takes long time to converge. It's easy to configure. It's work in multi-vendor route environment. So if we consider different routers from different vendors or from different companies, RIP can still work fine between different routers or different multi-vendor router environments. These are the main features of RIP protocols. النيو بقى الابديتد protocol for distance vector routing protocols is enhancement Inter Gateway Routing Protocol or EIGRP. This is the new protocols for distance vector routing protocols and try to update بقى the disadvantage or the problems in RIP. فit uses main features of EIGRP. It uses triggered updates instead of periodic updates. And we also said that it uses bounded or partial updates. So we'll not send full routing tables. We can send only part of the routing table with the many changes. It triggered updates. It uses hello packet to discover neighbors. Here hello protocols. When we start at the beginning, each router will send hello message to different routers, neighbors router, to know to exchange the IPs and know how many routers around me or to discover neighbors routers. So we send hello message at the beginning to discover each other يعني. فit support hello protocol to discover a neighbors routers. It support variable length subnet mask. So it's classless under classless category because it supports variable length subnet mask and also support root summarization or automatic summarization. This we'll talk about it and in the end of the lecture. It uses topology table to maintain all routes. So it builds or known the topology, the all network topology and put the topology inside the table. Unlike a RAID مثلا can عنده local view or incomplete view about the network. It's classless طبعا distance vector routing protocol عشان support variable subnet mask but it's classless distance vector routing protocol which is implemented by Cisco. Okay. Any question? And this بس يعني some features to memorize يعني about different protocols. If I need to compare مثلا between a RIP and EIGRP, the main resource مثلا for example you can consider here periodic updates, here trigger updates, and here make load balancing, split horizons, here support hello packet protocol, classless protocol, الريب طبعا class for protocol. So this to compare between a RIP and EIGRP. Back to RIP بقى, what we need to discuss in the following slides. We need to discuss the main characteristic or functions of a RIP protocol. We will discuss the automatic summarization and how we can solve different problem of a RIP. But first, continue to the previous يعني slides. The other characteristic of a RIP, it's classful routing protocols. طبعا it's distance vector routing protocols and classful. The metric we used here to detect or to calculate the best path using the hub count. So I will always select the best path at the minimum number of hubs. So I will select the path with the minimum number of hubs. So the path with minimum number of hubs will consider the best path for me. Unlike مثلا other protocols that can consider مثلا the path with maximum bandwidth, the path with minimum delay. Here for RIP, I consider the best path will be the path with minimum number of hubs. طبعا الروت الماكسيمم هاب كاونت will be 16. So if the routes with the hub counts greater than 15, I will consider it unreachable. So the maximum length for any routes for me is 15. If the number of hubs in any route is 16, it means that it's unreachable. Okay, the maximum number of hubs is 16, and if the hub counts greater than 15, it will be unreachable. وطبعا it support periodic updates, and these periodic updates every 30 seconds. So every 30 seconds, a RIP protocol will send updates, and these updates will include all routing table. Okay. This is the RIP message format. طبعا في data link header, IP header. What we care about is the RIP message component. فالRIP message contain root entry and a RIP header. A rib header has command, version, and zeros. طبعا zeros this for future يعني any protocol support some fields كده to be zero for future extension because this may be used in the future to support any other functions. But this is for future use. The version is the version of rib. It's version 1 or version 2. Here we have rib version 1 or rib version 2. So we will define the version of the rib using the version. The command to define the type of the message. If command is 1, it means that it's request. I am sending to other router, I am requesting information from other routers. If it's 2, it means that I reply to this request because some router may send request. I need مثلا to know the the distance or the hop count to specific route, or I need to collect information from different routers. So I am requesting information from other routers. So I will put on the command 1. It means this request message. If in the command is 2, it means it's a reply message. Okay. The root entry بقى contains address family identifier, IP address and metric. Address family identifier to indicate if this message will have IP or will not have IP. Because in the time RIP was invented, there is IP protocol and other protocols. We may have IP address or not. But this is to indicate if I will have IP address or not. For example, if this family identifier is 2, it means that I'm using IP. If I am request full routing table, I will set this identifier with 0. It means that I am requesting full routing tables. But this is identifier to specify if I am requesting full routing table, if this message contain IP or not IP, or using other protocol. And if this IP طبعا we'll put the IP address and we'll put the metric, والmetric here is a number of hops between 1 and 16 لأن الماكسيمم is 16. Okay, that is the main component that will be included in any RIP message. Okay, any question? And this part is يعني to memorize also, only يعني ما فيهوش no mathematics or no big understanding يعني. You can understand only the main concept, but most of things is to be memorized يعني. Type of the message here we said in the command will define the type of the message. So type of message, we have two types of messages. We can send request message if we need at the beginning to reach to any interface or collect information about any interface. So I am sending request message to request some information, and request all enable, and this request message enables router to send the routing table for me. So I'm collecting information about the routing table or interfaces around me or neighboring me. And to reply to this request message, we can send response message in this case to answer to a specific request from specific routers. So the RIP message can be request to collect information or reply with the answer. طبعا الريب support classful protocol. It's considered as classful protocol, so the IP address will be under a specific class A, class B, or class C. So it supports specific classes. So no need to send a subnet mask because we already can detect the class type from the beginning of the IP header. I can detect the class and support 3 classes. And so the RIP is classful and doesn't need to send subnet mask in routing updates. Okay, and support 3 main type of classes. This is example بقى for the typical or the easy topology that I can use RIP on it. For example, here if we consider 3 routers R1, R2, R3, and with this IP address, so all this IP address belong to class C. So all this IP address, I can detect the class for this IP address, so it's classful. So it's easy to implement a RIP in this case. The class is already known, class C, and all IP address can be easily handled with a RIP. For example, here we have three routers, five different IP address. So we can easily consider RIP in this scenario because all IPs is classful and RIP support classful updates. So it's fine. I will not have any problem for such topology to be implemented. So at the beginning, how bad to identify or building routing table or to collect information, we use a network command. So a network command enable a rep on all interfaces that belong to this network. So at the beginning, for example, router 1 belongs to two IPs, 198, 192.168.2.0 and zero point 1 and point 2. So at the beginning, router 1, for example, will run not network interfaces for those interfaces. So I will identify or initialize my interface at the beginning to collect data about these interfaces. Then I will advertise updates to other routers every 30 seconds. So each router will, at the beginning, this initialization, yani this step can be considered as initialization. I am collecting or identifying different interfaces connecting to each router. Then I will send these updates to the neighbor's router every 30 seconds. Right. When bad a problem happen, or what is the benefits بقى, what's automatic summarization and what's the benefits of automatic summarization? If we now have modified topology, what we will modify here? We will keep this ID, this subnet or ID address the same, and this belong to class C, and but I will add other IP address here. Okay, and this IP address is classless, doesn't belong to a specific class. And now we have two groups of subnets or two groups of IPs. This IP can be belongs to classful IPs and this other IP is classless IP. So here this may cause a problem with REPL and REP support only classful updates. This one thing. The other thing, and this all three IPs can be summarized بقى into one IP address. So we have here all these IPs belongs to 172.30 can be combined or summarized into 172.30.0.0/16. So the three IP address here 172.30.1 and point 2 and point 3 can be summarized, and this IP is classless, can be summarized into one classful IP address. You see what automatic summarization make? So I summarize a different IP address that belong to the same classful IP into one IP address. Now why we make this? What are the advantages of make this? Hmm. First, to avoid any problem in a RIP when dealing with a classless IP. I can avoid and combine all classless IP address belongs to the same classful IP address. It will يعني simplify things in RIP. The second more important advantage or more important reason for using automatic summarization is to decrease the number of entries or number of rows inside the routing table. So now, for example, R3, instead of including in the routing table three IP address, 1.72.30.1 and point 2 and point 3, so I R3 will put three entries. I can summarize all these IPs into one entry, and in R3 I will put only 1.72.30.0.0. And when I need to send to any subnet or any IP address under this summarized IP, I will send to R2, and R2 will manage بقى send to 1 or 2 or 3 according to the destination address. So in R3 I will consider only one entry in this case. فالريب automatic summarization, الريب automatically summarize a classful networks into one IP. So here I combined three IP address into one classful IP. So I summarized all this part as a one IP. So I removed all this part where I will reduce in R3. Then طبعا السايز of routing table is a problem in RIP and I have to put every address inside the routing table. We may have a large network, very long routing tables. Automatic summarization is useful in this case to reduce the size of a routing table. Okay. Now, here after this summarization, we define a boundary router. So this is in the border. I have to go to this boundary router. R2 in this case, we name it boundary router. What's the definition of a boundary router? Boundary router summarize a RIP subnet from one major network to another. Here, if I need to if I need to communicate another this boundary router summarize a subnet address from one major network to another. Okay, that's important to know what we mean by automatic summarization. Automatic summarization, we summarize a specific part of the network to be under the same classful IP address or classful subnet address, and a boundary router will be used to summarize this subnet and make a communications or manage a communication between the different major networks. Okay. This automatic summarization and this a boundary router. So a boundary router here will be R2, which will summarize R RIP subnets from one major network to another. Now to communicate or to enable the communication or the exchange of the packets between different routers using this automatic summarization. If a routing updates coming from same network, so for example, R1 sent to R2 or R2 sent to R1, so it inside the same network, we make summarization for it. In this case, I will send or I will include in the routing table the detailed subnet بقى. يعني for example, R1 will include 172.30.2 and 172.30.1. So R1 should include by detailed and I1 inside subnet, inside the same subnet or inside a major network. Here we could define this network into two subnetwork مثلا. R1 inside this subnetwork it will include 70.3.2 and 70.3.1, and R2 the same will include 70.3.30.3 and 172.3.30.2. So R1 or R2 belong to the same network, so it will include all interfaces or all subnet in the network table. But R3 should R3 include 70.3.30.2 and 172.30.3? No, R3 will include only summarized subnet 172 0.30.0.0. If routing updates exchange between a different interface from between different networks, so I will use in this case the classful subnet mask is applied. If I'm using, I'll make a lot of exchange updates between different networks, I will send the classful subnet mask or the classful IP. This is between a major network, but inside the same network, I will use a detailed IP or a classless IP inside the same network. Okay, clear these two rules. Inside the same network, I'm using all IP as it without summarization, but between a different network, I'm using summarization and sending only a classful subnet mask. Okay, clear? And rep using uses automatic summarization. طبعا المين reason to reduce the size of the routing table. So instead of including all IPs, I can include only a classful IP address in R3. It reduces يعني the main reason of automatic summarization to reduce the size of the routing table. فالادفانتج طبعا of automatic summarization the size of routing table is reduced وsingle routes are used to represent multiple routes. فهير مثلا I will consider all this part I will consider all this part of the network as a single route while it represents inside multiple routes. فsingle route are used to represent multiple routes. And the disadvantage بقى of automatic summarization it doesn't support this contiguous network. In this example here I have this IP address and I have this IP address. So these two IP addresses can be combined. But in the middle, I have different IP address. So this network is considered discontiguous. There is problem in the middle or discontinuous in the middle. If I have this two IP address 172 and 172 near to each other, I can summarize them. But due to discontinuity, new IP address 209 and 209 make this continuous in the network. But this continuous in this case electronic summarization will not work لأن I can't summarize this branch and I can't summarize another branch. So in this case electronic summarization will fail. It doesn't support a contiguous network. A contiguous network or contiguous topology like this make problem on RIP and may cause the RIP will not converge. In some cases, a RIP can't converge in some contiguous networks. One solution to avoid this is to allocate the network address carefully to eliminate a discontinuous network. For example, this IP address, we shouldn't include this IP address here. It's better to use other IP address. But it's better from the beginning to configure the network to be continuous network, not contiguous network. But this one solution to avoid يعني distribution of the IP address by this way to avoid this contiguous network. Okay? Any question? So now we finished the first part of